we are going to present the so-called area monitoring system, and the area monitoring system, maybe you perhaps already knows. It's a quality assurance of the for guarantee the right subsidies for agriculture. And basically, many member states, it is part of the AJAX system. I would like also to, before to get into the presentation, to underline what Georgios said in the presentation of the slides before to get into the breakout, the rooms, that there is a lot of diversification and within the member states in using determined technology, for example, AJAX system or IMS systems or other systems like FADN. So there is an homogeneity in terms of the mandatory of use of some instruments, for example, the AJAX, but there is a lot of discrepancy and differences in the technology used by the member states on this technology. So we can move to the next slide, Blanca, thanks.
Okay, yeah.
Yeah. Well, this is the agenda for my today workshop. Well, I divided the presentation, the workshop in some macro chapter. There is will present. There is a little introduction on area monitoring system at higher level. Then we pass to the regulatory framework for the MS that is behind the idea and of the MS. Then we are going. I'm going to switch to the description in detail of what the MSA is, showing the key aspects and the potential benefits nowadays and in the future, for what Georgios said before. So not just focusing on how this instrument is utilized nowadays, but also how we can see the potential benefits for the monitoring and evaluation of the country strategy papers for the next common agriculture policy. We are going to explain more or less I'll try to be as much as simple as possible on how it works, DMS. So from the what's called the coordination side, that's basically the paying agency side, and from the farmer side. Then I would like to show also the data sources that is behind the use of the MS, talking about the satellite data. In reality, not also on the satellite data, but also on the geotagged photo that is part of the data sources utilized by the area monitoring system. And then the last chapter is how we can see these MS as potential data sources that can support the monitoring and evaluation of the future country strategy paper for the new common agriculture policy starting from 2027. We can move to the next slides, Blanca, thanks. More or less this introduction has been done before, but okay, we in the beginning, in the first stages of the Tools4CAP project, we made this inventory of that is available online, and I encourage you to take a look at that, or the instrument that the member states are using to design and monitoring the country strategy paper. We divided this inventory in 4 macro category: the stakeholders needs assessment tools, policy choices supporting tools, policy analysis tools for evidence-based decisions, and monitoring and data collection tools. Today, we are focusing on this fourth tool. So MS is inventoried as a monitoring data collection tools. We can move to the next slide. Thanks. Here we started for the introduction. What is the area monitoring system? The area monitoring system, so-called MS, for the Common Agriculture Policy, is a new initiative by the European Union that is focused on monitoring the agricultural activities and the land use in the member states in more accurately and transparency and efficiently way. It's focused on to ensure and guarantee the compliance with the Common Agriculture Policy instruction, which provides financial support to farmers and promotes sustainable agricultural practices across the EU. As I said before, the area monitoring system, it is quite new instrument that is part of the IAC systems, and it's focused to guarantee to the farmer the right subsidies they can have according to the practices that they use, the yield that they are producing, and the number of hectares that they have. The area monitoring system, helps basically to systematic and continuous monitoring of the territory, agricultural territory, of course, at the moment, and contributes to improving the quality of the integrated administration and control system, because it's part of it, and of the geospatial aid application. What is the geospatial aid application? The geospatial aid application is a pre-established aid application that the farmer has to compile to guarantee to have the subsidies. And the GSA is also part of the IAC system. We can move to the next slide, Blanca, thanks. Here I tried to show a sort of workflow on how the agricultural monitoring system is working nowadays. There are, as I said before, there is discrepancy on the between the member states. So in my showcase, I take into consideration above all the experience that we have in Italy. So take into consideration of this. Basically, as I tried to say already before, the area monitoring system, it's a sort of quality assurance system that should help the farmer to declare in a most accurate way what they have to declare to get the subsidies. And from the other hand, to help the paying agency to check currently if what the farmer declare is right or wrong. So the workflow here, I don't know if it's clear enough, but more or less, MS. It's the link between the GSA, that it is the this application that the farmer is obliged to compile to receive the funding, in which they already have the polygon of their farmer. It's on the GIS systems, the so-called LPIS, and the IX systems on the LPIS side. LPIS, it's main land parcel information system, and basically it is the GIS background of the IX system. So the LPIS system precompile the application, the GSA application, based on the plots recording on the system. The farmer make their own application based on that. But after that, before the AMS, there was a double check by the field visits on the inspection on the fields in order to see if what declared is right or wrong, based especially on the type of crop that they're going to use or the practices that they are going to use. With AMS, all this check is made automatically by the use of new technology, for example, the Earth observation. So when the AMS check that everything is okay, nothing's changed, the farmer can get their own subsidy as they declare. If something has to be amended, so MS see some discrepancies on what the farmer declared, they can send back the application to the farmer in order that they can change accordingly. Once this is done, the MS communicate with LPIS that make its own changing based on the quality check. We can move to the next slide. As I said before, the MS, it's basically it's a brand new system. In fact, it became effective starting from the 1st January 2023, where the member states decided to establish gradually to implement the system. But from January 1st, 2024, we can say that the MS is fully operational in all member states, with the difference that we evidenced before. So if it is mandatory that all the member states have to have their own IX, there is technology differences between all the member states. And starting from January 1st, 2025, an eligibility coordination is considered monitorable when it can be monitoring using satellite, Sentinel satellite data. So we are facing a sort of mandatory using of MS for the next future. Next slide, please. Okay. All right. Here, introduce a more detailed description of on how the area monitoring system is basically built. And I'm going to show some key aspects that are important to mention. The first one is that this new system is a satellite-based monitoring system. So basically, the AMS uses satellite data, especially coming from the EU's Copernicus program, to monitor the agricultural land use, the crop types, and other relevant parameters. It is important to say that it's a real-time data that provides accurate information on how the agricultural lands are managed. The two main sources of the satellite imagery come from Sentinel-1 and Sentinel-2, freely available Sentinel data coming from Copernicus. The Sentinel-1, it's a radar satellite, rather the Sentinel-2 is an optical one. The important things to say, it's that brings the DMS to be very interesting in real time is the fact that the imageries coming from the satellites are available every 3 or 4 / 5 days, and where before these double checks were made by, as I said before, to the field visit or orthophoto. The principle that is behind the agriculture monitoring system is the fact that the information from the Sentinel satellites are used to verify the agriculture activity in the parcel. So, for example, the Sentinel-1 data provides radar imagery, and the Sentinel-2 provides a low-resolution optical imagery. Yeah, we can move to the next slide. Satellite data is not the only technology that has been used by the MS, because there is also an automated data processing system that has to combine the data coming from the Sentinel, along with multiple other data sources. One in the LPIS. It could be also, by the way, some field visit. We have also the geotarget photo. And the land parcel are assessed using a system of colored flags, also called traffic light systems that we are going to see afterwards. So the MS helps in assessing compliance with the common agricultural policy requirements, but observing land management practices. This can include tracking crop diversification, permanent grassland maintenance, and environmental measures. And the data can be used to identify areas where there may be potential non-compliance with the CAP rules, reducing the needs for on-site inspection. The use of the MS brings to a reduction of the need of the physical inspection and in this way, cutting the administrative costs and making the monitoring process more efficient and more faster. And the automatic processing and analysis of satellite data enable timely identification of issues, for example, that years before needs more time. Next slide, please. Of course, the farmers as well are encouraged to use DMS. That somehow it's seen as a sort of control, but this use can help them to a faster decision making and competence management. So it could be useful even for them. Another thing's very important, that it's important now, but especially I see a sort of inch for what I would like to show at the end of this presentation. So how this AMS could be seen as a potential new instrument also to the new to detect some new indicator of the CAP for the next CAP 2027, especially on focusing on the text on what's called the calculation of environmental sustainable indicators. Is the fact that the MS supports the EU goals of sustainable agriculture sector by ensuring that the farmers adhere, for example, nowadays to practices that protect the biodiversity, to improve the soil health and reduce pollution. The last point is that the MS implementations must consider the data privacy, that it could be seen as an issue, ensuring that the information about individual farms or farmers is protected according to the EU regulations on data protection. We can move to the next slides. All right, so what are the what are the potential benefits that the area monitoring systems already brought to the paying agency and the farmers, and what can bring also in the future? For sure, the area monitoring system increased already the transparency and accountability in the agricultural sector. It guaranteed, thanks with his checks, a more efficient allocation of the CFP funds based on the real-time data, and enhanced the support for environmentally friendly and sustainable farming practices. This last aspect is what, for me, it's important to see the area monitoring system as a potential new instrument for the future for the calculation on environmental sustainable indicators. Yeah, we can move to the next slides. Just a second. Okay. Here I try to explain also with graphically how the MS works. From the coordination side, so we can see from the paying agency side and from the farmer side. So from the coordination side, more or less it represents another way to see the first workflow that I showed in the beginning of my presentation. So it's DMS, it's the link between the LPIS system and the GSA of the application of the farmer, and the IMS operates on the IX systems, especially in what's called the reference parcel of the systems polygons. And it's an element of data verification and for a possible update of the reference parcel that have to be updated on LPIS systems. DMS operates on the application, the geographical application of the polygons provided by the farmers, complete with their declarative attributes to verify the compliance of what they have declared. We can move to the next slides. Here there is a figure that somehow tried to explain the so-called traffic light systems that I tried to introduce in the previous slides. So the results of the MS will be periodic over time until the end of the survey season. The farmer receive, once they present their application, an outcome on each polygon referring to a specific intervention. In terms of green light, that it means, okay, the application is correct. What is declared has been double checked and it's confirmed by the satellite. A red flag where the system said, okay, there is no rules. What is declared is completely wrong, and there is no space to make any correction on that. So the subsidies is not possible. And a yellow flag. The yellow flag is one that is a doubtful on the declaration. So when the farmer received the yellow flag, he has a certain period of time in which he or she or they can make their own modification and amendments on the applications, on the polygons, and in order to be eligible on the declaration based on the observation on the satellites. One is done, they present once again the application to the PIN agency. The MS checks once again, and if the declaration is correct, the green flags will be erased. Then there is also the white flags. The white flags is when there is no action, still no action. So when the checks has to be yet to start. The results will be provided massively at each deadline, but could be queried promptly through specific services, for example, API or web service system. We can move to the next slide. Thanks. From the farmer point of view, the producer must be informed periodically on the temporary outcomes of the MS. So in terms of green, yellow, or red flag. At the end of the survey season, applications will be considered payable when the doubtful cases has been solved and become green. And the producer, okay, must have the possibility in terms of timing to modify the declaration according to what the MS checks. And nothing. We can move to the next slide. Here there are some theoretical notes. So basically here, okay, there are some EU regulation that introduced the MS. For example, in this EU regulation 2018-746, the member states give the member states the right to make use of an alternative method to carry out objective checks that before was made just on the ground truth on the field by inspectors. And using the central images produced on average every 5 days, it is possible to perform multi-temporal analysis and on each declared plot. And by measuring the vegetation trend or indexes called NDVI using special software. It is possible to objectively verify the agricultural activity carried out by the farmer. We can move to the next slides. Here I try to give some, even some example of concrete example on how the mass functional in terms of concretely. Here I have like 4 images with the phenological cycle, and depends on the color of the plots. Okay, there are different crops. This is in Italian. In reality, we have different crops on each of these this photograph. They show that there are different crops on it. And this multi-temporal analysis of the images allow the LPIS systems to understand how the state of vegetation of a plot varies over a period of time, and therefore allow also to characterize the agricultural activities carried out by the farmer using specific markets. It means that, for example, if in application, the farmer declared that he cultivated his plot on, I don't know, maize, okay? With the MS can check if it is correct or not. Based on these colored images, for example, the MS can see that in reality, there is also just grassland on it, and the declaration is not correct. We can move to the next slides. Here, there is the difference, for example, to detect the vegetation index, the NDVI. That is possible thanks to the Sentinel-2 users, which allow us to evaluate the state of vegetation of a land on a date. So on the left side, we have the 2 color images, and on the right side, we have the NDVA, and we can detect the vegetation index, and also thanks to NDVA, we can detect if what is declared by the farmer is correct or not. We can move to the next slides. Here again, a concrete example of on how the area monitoring system works. So here delimited crops with different phenological trends. Here there is the delimitation crops with different phenological trends. Okay, here it's possible to see the difference between the orthophoto and the satellites. On the orthophoto, it seems that this particular plots, it's cultivated just one type of crop. With the satellites, it's evident the fact that there are 2 crops on side of it. And so when a farmer compile the application based on orthophoto, the satellites can see that in reality there are 2 different crops and this has to modify of the GSA and also on LPIS. And so the new declaration will bring to the fact that the farmer has to declare 2 different types of crops. Next slide, please. Here there is another and the last example. we have GSA segmentation and correlation markers, even evidence that the GSA show just one crop, but the satellites data show that in that polygon there are two different crops. So we can move to the next slides. Here there is a workflow of the satellite monitoring, how it works. More or less, it show what has been said before in this diagram. So the plot being monitored has not been yet been evaluated. The corresponding flag is white. Then the demand plots are assessed using the available satellite data. Then after that, the flags and markers are submitted for analysis by farmer. Then once again, the plots are submitted for analysis by the back office technicians. And the FAR produces the necessary documentation to demonstrate the consistency of the declaration and submit it for review by the back office. Then the supporting documents made available by the farms are available to the technical specialists, and the closure of assessment is can occur do a time-lapse acceptance of the monitoring outcomes, saying that what is declared is correct. We can move to the next slides. Here we introduce what is the main things in our presentation. Try to imagine the MS as a potential data source that is supporting the monitoring and evaluation of a future CAP intervention. On the data source point of view, the area monitoring system is based on geotagged photos and satellite images. How these geotagged photos are used in the MS nowadays? They are used to detect the presence of one or more specific crops, for example, agreed upon in the executive project phase, the crop rotation in the field, and the presence of markers of agricultural activities. Next slides. But how these data sources can be used to monitor and evaluate the future CAP interventions? For example, we already know that these photos are quickly becoming interdisciplinary tools, studying a variety of different subjects. Okay, in general. The information from these photos can improve the monitoring and evaluation of future CAP intervention. For example, suppose the evaluation concern soil erosion using earth observation biophysical markers. In that case, these photos can cross-validate the presence or absence of gullies or other permanent erosional forms that are prerequisite in using specific soil erosion models. The same process can be used to verify other CAP indicators as biodiversity, presence in some plots, high diversity landscape features, and the soil biodiversity. We can move to the next slides. Yeah, thanks. The other technology behind the MS is the satellite images. How the satellite images are used in MS? They allow for a continuous and detailed observation of agricultural activities, ensuring greater transparency on precision in application of agricultural practices. Next slides. But how this data can be used to monitor it and evaluate the future CAP interventions? For example, they can contribute to obtain data on sustainable agriculture by providing information, measurements, and quantification of natural or artificial phenomena. They can detect practices that improve the rate of at which CO2 is removed from the atmosphere, and they can also create maps for the enhancement of biodiversity or detect field water consumption. Next slides. What are the primary challenges governance bodies continuing to phase in using MS within the diverse context of CAP strategic plans also in the future. The technological adaptation. Member states must integrate MS data into existing management systems. And in terms of interoperability, as Giorgio said before, it's not easy. Interpretation of data. The quality of the analysis depends on the quality, on the ability, sorry, to correctly interpret and the data collected. Also, the dialogue with the farmers. Involvement of farmers is necessary to ensure understanding and acceptance of the tool. Regional differences. Geographical and climatic diversity in the member states require specific adaptation of the MS. And regulatory adaptation, integrating MS into CSPs requires harmonization of rules at the national and European level. Last slides. So to conclude, the MS can become an important pillar for the digitalization and sustainability of agriculture in the EU. Not only to monitor the CAP commitment, but also to promote more resilient and innovative practices in the agricultural sector. Its effective implementation requires strong political, technical, and economic support.